Hello, everyone. Welcome to our Smarter Together webinar series. This is a series hosted by Georgia Tech, Smart Cities and Inclusive Innovation, really focused on how research can make a community impact and build in those partnerships. This topic today is a special treat for you. I'm very excited about it. And it's based on a project that we were doing this past summer, where Georgia Tech partnered with the EPA, Environmental Protection Agency, and the Georgia Centers for Innovation to work on a new data visualization tool that combined industrial economic data with economic or environmental impact indicators. And so I'm really pleased to introduce our first speaker, who will obviously introduce herself and then her colleagues. But we have Valerie Thomas, who is our Anderson Interface Professor of Natural Systems, who's dual affiliated with Industrial and Systems Engineering in our Public Policy School. So without further ado, Valerie.
Hi, thank you. As Deborah said, I'm Valerie Thomas, one of this fairly large team we have here of Wes Anderson and Lauren Haynes, who are also speaking today. And we're representing the work of 3 Georgia Tech PhD students, among quite a few other researchers. So that includes Yulin Jha and Nazanin Tabatabai, who are both PhD students in the School of Architecture. Yulin was focusing this summer on the local supply chains, and Nazanin was focusing on industries and indicators, and also the work of Cindy Azuero, who is a PhD student in industrial and systems engineering, and she was working on the case study of sustainable bioeconomies. So I now am going to turn things over to Wes Anderson from the U.S. Environmental Protection Agency.
The opportunity that Georgia Tech is giving us to talk about this here today. I would like to start off by thanking Georgia Tech's Smarter Community and Smart Cities and Smart Community Core program for making this arrangement possible. Then I'd like to just start talking a little bit about this life cycle perspective that we've brought to this project and sustainable materials management. So I'd like to start by just walking us into a way of thinking about our industries in Georgia and elsewhere from the life cycle perspective. So with sustainable materials management, we like to think about materials not just are not just associated with the waste that they generate at the end of the life, but also as a resource that we use and add value to throughout the value chain or supply chain of industries in our economy. So this is a network systems like perspective that we're bringing to this, and we're thinking about these important materials that we have throughout all of these life cycle stages, from when we're extracting them the ground or harvesting them, processing them, creating products from them, using those, and disposing or recycling of those at the end of their life. So this again, I said, is an important concept in sustainable materials management. And I'm going to switch to screen here. You can read a little bit more about sustainable materials management on the EPA website at epa.gov/SMM. It's important not just to have this perspective, but really to bring some quantitative information and data to it. We want to be able to quantify what potential economic gains and environmental impacts might be throughout this life cycle for products. So one thing that EPA has developed recently in support of this is a set of tools called the Sustainable Material Management Prioritization Tools. And these, I encourage you to check that out also. You can find it from epa.gov/SMM. these give us a sort of a national perspective on managing materials throughout their life cycle. But what we were really interested in, and getting to the purpose of this project, is that underneath the hood of this tool, we have something called the USEEIO model. So it's a complex environmental and economic model of our U.S. economy that captures all of the industries in about 400 different categories, from agriculture to mining, manufacturing, service industries, everything that it takes to get products out to the final consumer and take care of them at the end of their life cycle. But we really wanted to make this model more available and more relevant to, the final community stakeholders and the industries operating in these communities, the ones that are really making these decisions on a day-to-day basis that could really improve both environmental and economic performance of our industries, our supply chain, and reduce our environmental impact. So this is, in this project, we're trying to take this model down and sort of make it applicable to sort of Main Street, right, in the USA. There are a couple challenges that we have in doing this, and I'd like to go over a couple of these today. One that I'm just referring to is we have this national model, but we really want to capture it and be able to utilize the information from it at a local scale. So in order to do this, we have to do a couple different things. First, we need to be able to pair this kind of information with really local information. We have national information, national averages, but we really need to make it more locally relevant by pairing it together with local information. And this could include, on demographics in an area, sort of natural resources or existing industries that are present in an area. We want to see those. Another challenge of it is just sort of being able to model these industries as they're actually built and running in these local areas. This is a challenge that we're meeting with by taking the national model and building it into a state version of the model specific to a particular state, and we've been working with the state of Georgia on this for a few years now. So we have one that's more relevant to the industries in Georgia. We also have new technologies that we're interested in exploring that are of regional interest. And one of those is a biomass-based industries, fuels, bioproducts, and that's something that we also wanted to tackle in this project, and that Dr. Thomas will talk a little bit more about later. Finally, another challenge is that this model is just very, very technical in nature, and without going into all of the details, only people that really are trained in this type of modeling can really sort of use it in its raw form and the code that we produce to build the models and the raw kind of data files and results, which are these giant matrices. So we really needed to make it easier for others to be able to integrate into their, make it easier for them to use on a day-to-day basis. So one great way of doing that is making it more available and easier, more easily available on the web. So one of the concepts that we've brought to the table and worked on in this project is this idea of widgets, or sort of these reusable pieces that would provide kind of a graphical summary of results from the model, or allow users to use data from it without having all the expertise that you need to really understand the model. So this is something that the interns that Valerie introduced really contributed a lot to over the past summer, and that will continue to be developing and working with some communities in Georgia to actually develop some web-based tools around. So I think with that, I would like to turn it back over to Dr. Thomas. Or sorry, I'm going to turn it over to Lauren Hines, our partner from Georgia Economic Development.
and we also worked with LaGrange. Now, they each have unique needs. Jessup is primarily looking at using waste from biofuels to create biofuels, and also LaGrange is looking at how the automotive industry will be affected by the switch to electric cars. Today we're going to focus on biotech and the bioeconomy and looking at central Georgia. This is an example of a regional approach. What we're looking at here is census data that is collected for surrounding counties. You can come in and you can say, well, what surrounding county has the most logging? This might be a good one to locate a new pulp processing fuel center. We built this with the intention that any state could modify it. So you'll see the two different URLs. We have model.earth, and then we also have model.georgia.org. So depending on where you want to start, you can also jump between. You can choose a state. You can look at regions within the state. You can do address lookups. Once you select your area, you can also click and add additional counties. Where the widgets come into play is that after you filter by these census areas, you can then see how those local commodities flow in and the impacts they have, and then the downstream outflow and the impacts there. So to get even more detail on the impacts, we have heat maps. So here we see that timber is the biggest land use. If we want to sort by something else, let's say we wanted to sort by, let's go over here to solid waste. And we see that actually bread and baked goods produce the most solid waste. And then using those indicators, we can analyze which is the largest impact on the upper right here. So we see electricity. If we were looking at uses of land, water, and energy, and it's electricity production, versus timber having less energy use, but a very high volume of land use. The size of the bubble is the land use. Our new widget that we're working on right now has even more detail where once you see the commodities, you can come and say, oh, I'd like to sort by specific impact. So here we see that coal is by far the most significant energy impact. But since we're also looking only at a certain area, we can say, let me just see the ones that are for my area. And there we see that wood pulp and cardboard take more energy. And then we can compare the upstream and the downstream as well. And then lastly, before I turn it over to Valerie, I just wanted to show you how simple the widget code is. This is an example of the code that you drop into your web page. It calls all the components from GitHub. So these are all hosted for free. And you can basically take any of the widgets we're showing you today and just drop those into your site. Now, I will admit that for the next few months, it's a little challenging because we're still perfecting kind of the cut and paste process. But come January, we are planning to have a web challenge that we would encourage you to participate in which you'll basically come in and set parameters, specify your community in what impacts you're looking at and what industries you'd like to analyze. And by the end of the web challenge, you should have a site very much like I've showed you here today, geared towards your community. And we can host this just simply using a URL to pull up your community. So with that, I'm going to hand it over to Valerie.
Okay, great. So at Georgia Tech, in my group and in other groups, there has been quite a lot of work on what could be done to make fuels and chemicals from different resources, especially waste materials. And so it was a great opportunity with this economic input-output modeling system to see if we can understand with some of these potential new technologies, what would be the impact? Not simply, well, can we make this cheap enough and sell it in the market, but if these new kinds of industries and processes were established in Georgia, how would that affect jobs? Would there be other companies that would also benefit either upstream or downstream? And then to provide a capability for counties and regions of Georgia and decision makers to kind of make some kind of decision and forecast. So one of the things that we've looked at in our case study are the potential for using wood, not lumber, which is very high value in Georgia, but with lumbering operations, there's also some waste like sawdust that can be used for possibly other processes. And as I think many in the audience will know, the Southeast has an excellent infrastructure for production of biomass from trees. There's an established supply chain. There are existing businesses, and there are markets. People in the businesses in Georgia and the rest of the Southeast have really world-class capability in forest products. Now, if you look at something like biofuels today, there are pluses and minuses. There's ethanol is easily made from corn, but what is being talked about for the future is not corn, which can also, of course, be used for food. So there's a natural tension there, but more use of waste products or lower value inputs that still might be biomass. And there are quite a few of these technologies and companies that have early stage projects in development or are existing. And one thing I want to point to is the potential not just for fuels, which you hear a lot about, but also what are called sometimes intermediates, that it's possible to make chemicals or materials from wastes and low-cost biomass. And so there's a interest in these kinds of uses of waste and low-cost materials to make, first of all, something that has more economic value than fuels. Fuels are extremely important to the economy, but the price of oil is very low now. It's hard to compete with that. Whereas higher value products like textiles can fit very well with the economy of Georgia and can be made from some of these same kinds of feedstocks that's showing at a microscopic level. And so we have several existing research projects funded by the U.S. Department of Energy, and one in particular funded also by the U.S. Department of Agriculture in working through improving some of these processes to effectively be able to make not just fuel, but also higher value products. Our research work at Georgia Tech is on one of these kinds of processes, but there are several. There's enzymatic process, there's a gasification, there's pyrolysis. All of these, how they would work, what they would need, what they would produce, their efficiency are fairly well characterized already. So specifically, we've been looking at with a project funded by the U.S. Department of Agriculture and Department of Energy is using low-cost waste materials to make value-added items, not only fuel, but also all kinds of products that you might be surprised can be made from biomass and are currently, you also might be surprised, are made from petroleum products. One of our partners in this work is LanzaTech, which has a facility in Georgia at Soperton, Georgia. And they are a successful, commercially successful business. They use, in many cases, off gases from steel mills. They also have a project with gasified biomass in California to make ethanol. And then from that ethanol, they make other products that can displace existing materials. So our specific project, just to let you know, is to use Clostridia to ferment what's called synthesis gas. The synthesis gas is produced from what's called cellulosic biomass. That means essentially, wood, sawdust, something like that. Also can be garbage, municipal solid waste, using established technologies for gasification. But after we get this gas, we ferment it to make then the precursors of different products that can be made into plastics, essentially. And this can be a large market. And what we're trying to understand is not just how do you make this from a laboratory perspective, but if we did make this in Georgia, what would be the economic development? What would be the environmental impacts in, for example, Georgia? So what we've done in this project, and Cindy Azuero in particular, was to include a number of possible technologies like this, not only the one that we're specifically looking at, but also some of these what are called pyrolysis, fermentation processes to take the existing infrastructure in Georgia and the United States and just kind of open it up and add in this new industry, because we know what it would need, we know what it would produce, and so kind of connect it to the rest of the economy to then be able to evaluate jobs, downstream industry impacts, upstream industry impacts, and the environmental impacts. So in incorporating this into the U.S. environmentally extended input-output matrix that Wes introduced, we have to open it up, put in new factors that take into account these existing, these developed technologies that are our new proposed industry, to understand how this would play out for different areas in Georgia or other parts of the United States. So that's the extent of my shared comments, and I will turn it back to the group.
Thanks, Valerie. Oh, go ahead, Deborah.
Yeah, no, and I just want to add that obviously if there are questions, to please feel free to type it on. I have a series of questions that I'm very excited to ask, but just make sure that you type in your questions in the Q&A box or in the event chat too.
I'm going to share my screen while we talk about the questions in case there's any that I can steer folks to. If you do go to model.earth, I want to show you how to find some of the starter pages. You'll see that we have our date posted for the January Web Challenge. That's going to be a weekend, January 23rd and 24th. It's very informal. We're working with both Code for Atlanta and Code for America. We encourage teams to start. In December, we'll have a couple information sessions to get you going. There's a good chance there will be some awards, and we'll give you more details on that. If you're a programmer and you want to jump in, or even a community person, a good place to start is to come up here on the right side. You'll see our navigation, and you'll see starter samples. From the starter samples, the first link is going to show you how to actually deploy your own website with what you see here. You could basically deploy this site, put your state on it, put your company logo. We would love to see company teams add widgets. It could even be something like a pro version that they, like say have an added map widget that they maintain because they have satellite access. We would love to see those things added. The second link is the actual widget. So there you'll see many of the things we showed today. You can see individual charts. One of the nice ones here I wanted to mention that Nazanin created. She's, in addition to being an architecture PhD student, she's also a computer science student. Did a great job using D3 to structure this so you can pick and choose different levels, jump between them, highlight them. And then our other architecture student, it was Ilan. He's been working on a really cool sand key chart process that shows the inflow on one side, the commodities in the center, and the outflow on the other side. And then we also have our heat maps as a standalone version. You can see you could just have that as one of your content pages if you wanted to emphasize that. Just super informative, we have a whole bunch of different ways you can slice and dice this. If you want to see a lot of detail about it, you can actually get the levels of each indicator filtered by specific indicators. Here's an example we did for if you wanted to see like the impact of tires alone. You can see the inflow and outflow for tire rubber. So, Deborah, do we have any questions so far?
Thanks, Lauren. So I'll start off with a couple of questions. So I can see this being really interesting for a community's economic development strategy. So once you have this information, you can really start to plan what types of potential for clean tech and biotech industries that could be in a community and really support that. But for a lot of communities, can you take us a step back in terms of like, where would they get this data? How would they actually use this tool that you've developed? You know, where is this tool being applied in order to really inform the economic development strategies, especially in Georgia?
Wes is really our data expert. I'm going to let him field this.
Well, I mean, first of all, our work in Georgia is really a pilot project to try to make this type of information and this life cycle model applicable for the first time at this community scale. So I don't know if part of the question was, well, where has this been demonstrated and to be useful or used already by a community? Then we're still, we're in the process of getting there on that. But I can say that there are a lot of users of the model right now directly in industry. They're using it for things like their carbon footprinting and their sustainable supply chain analysis. And also some municipalities in different parts of the country. Alameda County in California, for instance, they've used the model to look at the impacts of all of their purchasing in the county to try to figure out where they could act to reduce their footprints. But this type of use of the model in this really dynamic way where you're incorporating new technologies and really matching that with this location-specific information on the population and existing industries there and so forth is new and that we're piloting in this stage.
Yeah, and it seems pretty oh, go ahead, Valerie.
Yes, I wanted to jump in on this to say that it's not just a one-way from the researchers to the communities, that actually in our work this summer and in the springtime in setting this up, we had some conversations with people, especially in this case I was thinking about in Southeast Georgia and the Jessup area, and heard about the technologies that they were interested in exploring. And so in setting up our work, then we included those technologies in our modeling. And that was super because we want to be modeling things and working to develop the tool in ways that are actually directly related to the kinds of businesses and industries that they're people working to set up. So I'm offering that to the audience so that there could be more suggestions from entrepreneurs, from economic development bodies of what they'd like to see. And we can't do everything, but we can try.
No, this is great, and I appreciate how comprehensive this tool is, especially in terms of the level of data that you've been able to collect from the environmental data to the industrial systems data, but then how you were able to kind of display that in a really strong visual way. So even that you're not a data scientist or as literate, you can kind of see where those flows are. So, but for a community, can you just take a step back? Where do they come up with this data? Like, how would they really think about starting something like this?
Well, a lot of the data that we're putting into these applications is actually already publicly available, and we through our research and like over this summer, we've already incorporated it in. So as Lauren gave one example, like we're on that local startup of the web application, you can sort of enter your county information in there or the industries that you're looking for, and we'll pull in, the tool will automatically pull in employment data and the presence of those industries in your area and so forth, and could give you a map view, like visualization also of that flow of materials in your own community, or sort of some of the demographic characteristics around the community. So that a lot of that data is going to be there for them already. Where we want more, we would like more data is, if they can improve upon what's publicly available, or like Valerie was mentioning, they're really looking at investigating a new technology where there's not publicly reported data for it that we can draw on. So we really have to get into the modeling space there and working with the partners there to really get good information on those industries that they're looking at.
Yeah, I'll jump in again here that encourage the audience to look at the tool. I was playing with it this morning for one region in central Georgia, and I could just punch on employment and see which economic sectors are providing the most economic employment. And for this particular area I was looking at, it was schools. That was interesting. And to see that was so important in the economy of a certain area. And so in each area, in each county region, the information is there for not just to play with, but actually to use it in thinking through future economic development ideas and how it's possible to build on what regions already have and where they might want to work on developing new businesses.
Interesting. We got a question from the audience, and maybe this is a question for you, Valerie, but it's a question on where is the research located? Is it located in Georgia Tech or elsewhere? And I imagine this is around the data sets and the tool.
So where is the research located? It's distributed, and there are different pieces of it. So the headquarters, and in my opinion, for the U.S. Economic Environmentally Extended Input-Output Model is the US EPA. And there's also work at the national labs contributing to that, and I'm sure that Wes will add to my answer. And then also driven by Lauren Haynes and others for the Georgia application at the Georgia Department of Economic Development. And then some of our work at Georgia Tech is using that we have some knowledge of how to work with these economic input-output models, of adding some of the technology and research knowledge we have into those models. And then the research on these applications, such as biofuels, is happening in our particular project in collaboration with scientists also at Northwestern University and at the University of South Florida. So there's quite a network of overlapping research. And Wes, I think you and maybe Lauren can add to this, to my answer, or correct it.
No, I think that was a good answer. I'm looking at the question. I believe that you're referring to, Deborah, from Joel. And he was asking, is there any research using bamboo, Arundodonax, or other grasses as replacements for pine trees? So I think that is more of a question for Valerie.
So the answer is yes. We have looked at Georgia Tech specifically at bamboo and Arundodonax, it's a kind of reed, and there are perennial grasses such as miscanthus and switchgrass that can be used for both biofuels and bioproducts. And these are have pros and cons, excellent capabilities, and some pros and cons. It depends. But there's a lot of work on all of these kinds of things that we've been looking at. And for the kinds of technologies we were putting into the input-output model, they are, the term is sometimes used, agnostic to the different feedstocks. They can use different feedstocks all the way from municipal waste, which is really hard to deal with, something like Arundodonax, which grows very readily and also that's true of bamboo. And these other perennial grasses, which don't require as much input to grow as something like, a corn feedstock.
I think this is a really good also example of when we think of community research partnership, right? So we didn't touch upon this too much, but this really started out from the Environmental Protection Agency and Wes, your leadership in terms of you've developed this really comprehensive tool. You think there is a lot of potential and value, but it needs to be tried out. You connected it with Lauren at the Georgia Centers for Innovation to see if Georgia could be a good place to try this tool. And who could really help further develop the research, which is then how we connected it with Valerie and her ISYE public policy expertise to complement it along with our Smart Community course student. But a question for you, Lauren, is, why are you interested in really positioning Georgia, to try out this tool? What really is a reason to connect it with economic development?
Well, I'll give you a little background. We maintain a lot of directories, but it's very hard to keep them current. In this day and age, you've got Google, you've got Facebook. People really don't maintain listings like they used to. So it's much more important to go right to the source. So bringing in the census data, combining it with the Bureau of Economic Analysis data, is just a much more organic, and it's not going to dry up. It's not going to be like 5 years later. We used to maintain a list of environmentally friendly products, but it was never going to be comprehensive. Well, now we can be truly comprehensive. I'll show you an example here of that Valerie was mentioning, how you can look at an area. You just get such a great grasp of what an area does. I just chose employment count. Now, I didn't realize, poultry processing was the top employer for the central Georgia area, followed by logging. But then if I look at the number of establishments, lo and behold, it's completely different. Logging jumps to the top. I've got sawmills, soil. So it's a great way to get a snapshot of what's happening in any area and then add on to it. When we think about the next level of where I think this should go, it's that if you're a company or you're a university and you have a project, plug it in such a way where you could basically have an intern that would work directly with a state, would work with the EPA to add pieces so it would gradually expand to have, something that would serve you and your interest. Use it in a dissertation, use it for your mapping app. It basically solves a lot of the problems that I saw as a developer for the state, which is we were always bringing on a new contractor. They would develop this one little thing and it would be isolated and it wouldn't really have a life beyond a couple of years. So this way, if everyone is contributing, and they can still really control their part of the code, and you come to recognize that people have a knowledge base that they're good at, and it's not like someone's going to grab your code and just run with it. And if they do, it actually benefits you in most situations. So that's why we reached out to Code for America to help pitch this, to try to integrate it. We've used the same backend for our PPE equipment for the state for personal protective as a response to COVID. We use it for recycling databases. So it's getting a lot of use. And specifically, when you go to the top, you'll see a lot of the different categories here. You can dig into the search, and you'll see that you have different ways to dice it up, including using Google's autocomplete. So just a ton of really cool ways to kind of make sure that this isn't just kind of a one-off, that it just keeps growing with the EPA. And it's been super exciting for me to be able to nudge and push and see just the ease of use that's coming out of this. And the widgets that we're working on with the EPA are being used in a lot of their other tools. So you'll start to see something you say, I saw this here and now it's here. So that would be the great outcome. I'd love to see it plugged in by the Bureau of Economic Analysis as well long-term, because they do input-output flow. There's no reason why they couldn't also show the environmental impact of all that industry data.
We got another question from our audience, again, complimenting how the data visualization is great, and then asking if they're able to access the firm level data within the county industry.
think you're muted, Lauren.
Sorry. The answer is we don't have individual industries, but we do have basically separate JSON files that can be downloaded for the entire state. And Wes is working on individual states, so they did Georgia first. And when you combine that with the county data and the zip code data from the Bureau of Economic Analysis, you can get very granular. But in terms of individual industries, Secretary of State's often sell that data. I think it's about $500. Over time, I think that we'll see some of these, like Google search. Like right now, if you search the industries, you can click on an industry. It will take you to the Google map for that location. Then you get about 80% of the local industries. Hit and miss. You know, it's not perfect, but it's a good start.
Yeah, I just wanted to add to that most of the data that we're using and visualizing here are these large public data sets like the census, for instance, and for privacy reasons, they roll up the names of individual establishments and provide like industry-wide averages. But this is another place where we really wanted to go, a direction we wanted to go with the community partnerships, because some of the economic development agencies, for instance, that we've talked to, they have a lot of this specific information. And also just this idea of widgets. Well, we don't have to you don't have to give us this data and we maintain it for you. You can maintain it. You can keep that data on your side, protect it as you need to, and just try to integrate it with our model data. So if we can really work to that level, it's a great question, because I think we're going to be able to get to really more community specific type answers, and with that firm level data in cases. We just have to establish the partnerships and the level of comfort with our communities to be able to integrate that data, so they're willing to share that data and put it into these types of models and visualizations.
Wes, that's a good question to add on, is that, obviously we understand this is a really important pilot for Georgia, but you've also done this in California and elsewhere. How does that compare from your national perspective as you kind of roll these different applications out using the same base tool? And obviously the feedback that Valerie, says in terms of getting that community input that would then really affect the data and the results.
Well, and actually, so in those cases, Deborah, those communities found it on our own, and they're using sort of maybe hiring a consultant to work with a model in its more raw form that has that expertise. So we were only aware of it because they notified us or maybe asked us some questions about the use of the model there. But it's not something that EPA was directly involved in the creation of or had partnered with other local agencies like in this product. So this is really unique. There's no other project like this in the country.
Well, if that's the case, then can you share with us a little bit about what you plan to do in terms of your next steps? Obviously, this was a pretty intensive period over the summer. We had a really strong team. Lauren touched about it a little bit in terms of its ongoing connection with Code for America and obviously, coders. But what comes after this initial step?
So this is, I'll just share the screen again. And this is also was available on a separate view on the Model Earth website, but we'll put some of these, maybe Lauren, you could help put a couple of these URLs in the chat box for the users. But definitely with this particular project, kind of drawing on some of the information that we've developed in these widgets we developed over the summer and these visualizations that Lauren provided, we want to go ahead and try to integrate these into working, web applications. But we need to get them a little further along first. So our next step is sort of partnering with, hopefully partnering with the Code for Atlanta and group and Code for America to bring these web developers in that have additional web development skills and can kind of work on starting to integrate some of these pieces we've developed into the websites. And then we'll be working more with some of the communities in Georgia, which I haven't mentioned yet, but there are two communities that we've been talking with and wanting to work with. The Southeast Georgia group is one of those, and a 6 County Southeast Georgia coalition there, and also in West Georgia, there is the LaGrange Economic Development Authority and Troup County, and those are they sort of reached out to us on an early on phase and saying they're interested in having this kind of information and these tools at their disposal. So we'll continue working with them as part of this pilot phase, and hopefully other parties in Georgia, other communities in Georgia. Or industry groups and elsewhere will show some interest and maybe start using some of these tools on their own.
And then related to that, Valerie, where do you see the research going in terms of this next steps? Obviously, there's still more partnership to be done based on the local community and that feedback, but where does the research go in terms of this tool has been developed and what do you do with it in terms of taking it to that next level of research?
Yes, so one of the levels of the obvious next step is to really test how well do we think this kind of model is giving us reliable answers. It's risky for communities to develop brand new industries, and the idea is that this kind of modeling will help them understand what the kind of prospects are. And certainly we want to make sure that the kind of modeling you do with this economic input-output modeling at the local scale does correspond with some more specific practice. What have we seen in communities that did develop this kind of industry? Do we see approximately the same employment, environmental impact, and so on? And that can be quite, and especially in talking with some of the economic development leaders, like in Georgia, is a thing that's interesting is not only, can we get this one facility, maybe a major facility set up in our area, but what would it do to our whole ecosystem of industry? So that's something that from a research perspective and in providing service to the state of Georgia is for us to kind of vet and understand, does this give you follow-on impacts for your other industries, both the upstream and the downstream, and just how confident are we? Because we want to communicate that as well, that this is approximations, of course. We're trying to look into the future a little bit. And so we want to be able to provide understanding to entrepreneurs and to, local governments, kind of what they can expect and how well we can tell them what the future might hold.
Yeah, and I think it's obviously, to Lauren's earlier point, it has some downstream benefits in terms of recruitment, in terms of different industries that could come into an area and really being able to showcase the comparative advantage that that community would have, especially compared to, again, other communities that might not have this information as the industry kind of plots and plans. And then on the other side, it has huge ramifications for workforce development. In terms of the skill sets, and obviously coming from a university, what kind of skill sets are needed to support these types of industries that might be the comparative advantage for that local economy. So I can see a lot of different, I would say, additional benefits that come with this base data that can be incorporated in terms of discussion with the Economic Development Authority and the local community, but also once you have that data, how you can really connect it with recruitment and workforce development in terms of its next phase of future growth. if you will, for ongoing. So Wes is smiling. I think there seems to be lots of possibilities, Wes.
Oh, yeah, you're helping us. Those are great ideas too, and we people, others outside of our group, thinking about the uses of the model and all this research that we're doing, because that's the most important part. So thank you. Yeah.
Yeah, and I think it's an interesting kind of thing where you start with obviously Environmental Protection Agency when you have that kind of traditional environmental indicators, but then if you connect it to obviously economic development, and then of course where Valerie's really skilled in terms of the wider public policy and industrial systems engineering, that kind of input really showcases a united collaboration. And it's great that, thanks to you were able to choose Georgia as the first starting point in terms of the potential for this. And I can see a lot of ongoing work that could come from this, and know that this project is not done yet, but is very much a starting point. So for those that are interested, obviously, Lauren and Wes put some links out there that you can test and try. Like any tool and model, you can play with it yourself. And obviously, I'm sure you're open for feedback from our greater community as they play with this model a little bit. Thank you, Valerie, Lauren, and Wes, for this really great conversation. I think this is kind of one of the first presentations that you've done introducing this data visualization tool. So I commend you for doing that, because it's not the easiest to share with our virtual audience, but just being able to understand, the process at the beginning, the origin, and then again, the wider ramifications and applications that could be done with this tool is really beneficial for our community. Thank you again to our audience. If you have any additional questions, obviously feel free to reach out to us. This recording is also going to be up on our website, so you can look at this at your own time. Next week, we have another amazing webinar that's going to be focused on the economic and development profile for smaller communities. We have many more smaller, medium-sized communities than our large megacities, and how does a community of that size really develop a community economic profile assessment? And this was really a nice continuation from this group's conversation. And next week we'll be focused on Douglas, Georgia, so we'll use that as the model. Thank you again, everyone, and please take care, and we will stop recording and see you again soon.
Thank you, Deborah.